Now that we know how to complete the square that's in the form of x squared plus bx equals c, now we can learn how to complete the square with leading coefficients. And remember, the point of learning how to complete the square is so that way we can solve quadratic equations that don't necessarily factor easily. Completing the square, and we're given a trinomial that has a coefficient in front of the x squared term. We call that the a value. You have to first divide both sides of the equation by a. Remember, a is that leading coefficient, so you have to divide both sides by a. So remember, when you're dividing, you have to divide every single term of your equation. So let's say we have 4x squared plus 16x minus 8 equals 0. Because I have a leading coefficient of 4, the first thing I have to do is divide every single term by 4. So I end up with x squared plus 4x minus 2 equals 0. So when I divided by 4, this became x squared. 16 divided by 4 is 4, so this became 4x. And then 8 divided by 4 is 2, so this became minus 2. And then 0 divided by 4 is 0, so this stayed a 0. Now I can complete the square. I will put it in the form of x squared plus bx equals c. So I have to add 2 to both sides. Then I can complete the square by taking half of the 4 and squaring it. So half of 4 is 2, and 2 squared is 4. So I'm going to add 4 to both sides. Now that I've done that, I can go ahead and factor that trinomial. I know that it's going to be a perfect square, so it'll be x plus 2 squared equals 2 plus 4 is 6. Then I can go ahead and apply my property, my square root property. So I'll square root both sides. So I get x plus 2 equals plus or minus the square root of 6. And then subtract 2 from both sides. And I get my two solutions, negative 2 plus the square root of 6 or negative 2 minus the square root of 6. So here's another example, 3x squared minus 2x minus 1 equals 0. The very first thing I have to do is divide by my leading coefficient of 3. So then I'll end up with x squared minus 2 over 3x minus 1 over 3 equals 0 over 3, which is just 0. Now I can put it into the form of x squared plus bx equals c. I have to add 1/3 to both sides. And then from here, I have to take half of my b value and square it. So 1/2 of 2/3, or 1/2 times 2/3, ends up being 1/3. And then 1/3 squared is 1/9. So I'm going to add to both sides. So x squared minus 2/3 x plus 1/9 is a perfect square. So that factors to x minus 1/3 squared. And then 1/3 plus 1/9 is 4/9. And then from here, I'll the square root of 4/9 becomes plus or minus 2/3. And then I'll add 1/3 to both sides to solve for x. So I have 1/3 plus 2/3 or 1/3 minus 2/3, which means my two solutions are 1 and negative 1/3. So next example, I have 2x squared equals 10x plus 3. So the very first thing I have to do is move that 10x over to the same side as the x squared. And then I have to divide by my leading coefficient of 2. So when I do that, I end up with x squared minus 5x equals 3 over 2. Now I can complete the square. I have to take half of my b value, which is the 5. So half of 5 squared. So half of 5 squared is 25 over 4. Add 25 over 4 to each side. And then I'll factor that perfect square trinomial. It'll become x minus 5 over 2 squared. And then 3/2 plus 25 over 4 becomes 31 over 4. Both sides, the square root of 31 doesn't simplify, but the square root of 4 is 2. And I do get plus or minus on that. And then I'll add 5/2 to both sides. Because I have a common denominator, I can write it as one fraction. 5 plus or minus the square root of 31 all over 2. So this type of solving method is useful for projectile motion. So projectile is like when something is being thrown or tossed. So it's moving and it's also falling. So the motion of a projectile with an initial velocity, which we say VI, so that's or V sub I, which is in feet per second, and initial height, which we say h sub I, is modeled by this equation. H of t equals negative 16t squared plus v sub I t plus h sub I. So the t stands for time in seconds. That h sub I is the initial height. The v sub I is the vertical velocity, the initial vertical velocity, and then h sub t is going to be the length that is traveled. So for our first example, we know that the length is 15. We know that the initial velocity is 88 and the initial height is 3. So we want to know how long does it take for it to fall or move 15 feet. So we have to solve for t. So this is quadratic. So what we're going to do is we'll go ahead and move everything to the left-hand side. So that negative 16t squared will become positive 16 squared. And that plus 88t will become negative 88t. And then we'll move the 15 over with that 3, so we have to subtract 15. So 3 minus 15 becomes negative 12. Now I have a quadratic in the equation that's in the form of ax squared plus bx equals c. So the first thing I have to do is get rid of that leading coefficient by dividing both sides by 16. So that will become t squared minus 11 over 2x equals negative 3 over 4. So now I can complete the square. So I have to take half of 11 over 2 squared. So half of 11 over 2 is 11 over 4. And then 11 over 4 squared is 120. So I have to add that to both sides. And then I can factor that trinomial. It's a perfect square, so it'll be t minus 11 over 4 squared. Remember, that's always half that b value to get this number here. And this operation is always going to be the same. And then this will always be the square root of your first term. And then negative 3/4 plus 121 over 16 is 109 over 16. I can use my square root property. Square root both sides, getting plus or minus the square root of 109 over the square root of 16. The square root of 16 is 4. Then I'll add 11 over 4 to both sides. The denominator is the same, which means I can write as one fraction line. So it's either going to be 11 plus the square root of 109 divided by 4, or 11 minus the square root of 109 divided by 4. And getting approximate answers, since we're dealing with seconds, I would say that's 5.36 or 0.14 seconds.